So, do you think we should get going?
I think we should, yeah.
Perfect.
Two people are still joining, but we'll continue on.
Yeah, and then this session is recorded as well, guys, so just for your information.
Yeah, so just on the screen, you can see that please post any questions in the Q&A. That's myself on the top, Ronan Trainer, and Damien there as well, who's joining me today, and we'll be monitoring the questions and helping out with today's webinar. So thanks very much for joining us today, everybody. As you can see, the session is recorded and will be distributed to anyone who registered. Okay, so let's get going and jump straight into it today. So just a little bit about SmartBear. If you haven't heard of us before, we were founded in 2009. We've 11 global offices now, and we're coming live today from our Galway European headquarters in Ireland. And also the home of the Swagger Hub development team as well. So as well as
that's a good one. That's another.
Absolutely. A little bit about SmartBear as well. So we've been recently recognised by Gartner as a leader with embedding intelligent automation and testing throughout the delivery pipeline. And we also have some recognition from Forrester as well. Independent reviewers and well known. So after quite a while as a visionary and a challenger, we're now up in the leaders for that space. A little bit about the SmartBear product portfolio. Today our focus is going to be on ServiceV Pro. So ServiceV Pro allows us to create, configure, deploy virtual APIs and other services to ensure their availability. We have quite an extensive portfolio of tools now from Zephyr, which we acquired last year for test management, Hip Test and Swagger Hub from a design perspective, and then various tools from creating virtual services to collaborating on code, to shifting left and running automated tests from your own IDEs if you're a developer. And then from a testing perspective, plenty of tools across there, SoapUI Pro and Test Complete being the best known or most famous tools, I would say. Cross-browser testing, and then Load Ninja, which is a new tool that SmartBear developed in-house only last year. And this allows you to easily create tests on any web application and then generate that load and scale it on multiple browsers. So that's a new enough tool, but it's going down very well from our feedback from our customers who have used it so far. Okay, so today we're going to talk about mocking versus virtualization. We're also going to have a look at creating some virtual services in a few different ways today in a demonstration that we'll get to later on. Obviously using our tool ServiceV. So mocking and virtualization, to jump into it, the core purpose is similar. Basically, we're removing a dependency on a service. Okay, so that virtual asset or that mock is going to act in place of a production API. And what separates, or the main difference between mocking and virtualization is the depth. And when we look at it, mock services, and if you referencing the image on the right here, with mocking, regardless of if I send a request of what's the weather today or what's the weather this weekend, I'm going to get an answer back of the green highlighted response of 14 inches of snow. So mock services will have a small set of responses for a request, and generally that response is going to be static unless we have scripted those responses into it. So there's going to be quite a bit of scripting for us to be able to kind of generate, more than one or two responses.
So a question there for the audience: how many people have heard of mocking before? Not Mockingbird, but mocking services. how many, and again, adding to that question, how many people are doing a lot of not basic API responses, but more kind of, as Ron says, in depth, like, three different layers of responses. So how complex are they? So again, a couple of questions for you guys.
Yeah, and I'm going to hop on to the next slide because it's very relevant, and we'll launch a poll maybe to get some information about that question you asked, Damien. But even to look at mocking and virtualization, when we look at virtualization, then the virtual service that we create understands that there's context to the request, right? So basically, what's the weather today will return a certain response versus what's the weather tomorrow will return a different response. So there's a pool of answers that are returned based on the request. Okay, so essentially there's logic built into a virtual service. So it's going to behave like an API, and we can control things like response times. We can connect to our test data and data drive our responses back. So a typical scenario I always look at is, if I'm logging into a system and hitting a virtual service, passing, username and password with virtual services, and particularly with ServiceV, we can take those request parameters. We can dynamically build a query to pull relevant information from a database or our test data to return that information in our virtual response. While with mocking, we're going to send a request. It's either going to sequence through responses or randomize responses. And if we want to do anything more complex than that, we're going to need to, build scripts to control that, how those responses are dispatched. Those scripts are going to require maintenance, and there's a lot of time and effort will go into that. So, for example, on the screen here, you can see the different examples. What's the weather today? What's the weather this weekend is going to return different responses here if we have our virtual service built correctly. With virtualization as well, we're removing a lot of that requirement for scripting. Okay, so ideally, we want to limit the amount of scripting involved for our virtual asset. It should be easy to change, quick to change. We want to be able to go in and manipulate it, maybe have the API returning errors for us. And we can do this very quickly using ServiceV and API virtualization. So I will launch that poll, Damien, just while on the topic. So are you currently using any mock or virtual services in your testing environment?
So yeah, so again, it's just to kind of get a feedback from everyone. Like, some of you've heard of virtualizing, some of you heard of mocking, but again, it's the, as Ron said at the beginning, it's to understand the difference between both, the different how the depth of what you can do with virtualization compared to mocking. Obviously, some of us have heard of open source and all that kind of stuff, but again, once you get into, and more so, the APIs are becoming very, very necessary and an intricate part of the software development lifecycle. We even have its own API economy now at this stage. It's that important. So again, it's important to be able to kind of have control over the third-party APIs that you don't necessarily have, that you're trying to access and work with.
Yeah, exactly. So, third-party APIs or APIs that are controlled by another team.
Yeah, exactly.
And even yesterday, I was on a call with a customer and we're troubleshooting an issue. And they sent a request to an API and the API wasn't available. And the developer was not too happy on the call because it was working an hour before we started talking to him. So a typical instance or example where that API service that he's testing against is not within his control. It's controlled by another team. Maybe they took it down, or the server's not available, or they changed something that's broken his tests. And this is very commonplace and frustrating. Frustrating for a lot of companies and people we talk to as well.
Yeah, I just maybe a bit off topic. I hope the VAR wasn't API driven. And last night, for those of you that are interested in Champions League football.
Absolutely. I'm going to just quickly share those results just so you can see them. So there's majority of the people using mock services, a little bit of virtual services, a little bit of both, and some people who are not doing any at the moment. Okay, so hopefully we show you some examples. Using ServiceV, you'll download the tool and get started trying to build some services yourself. Okay, so why do we want to virtualize? If we look on the right-hand side, you see, typical layers of a system. And an application may look like it calls, a single high-level service. But underneath the hood, there's lots of different layers and lots of dependent services. There's a wide mix of service types from Java messaging services to data layers and web servers, and often in many cases these are managed by separate teams. And referencing back to that example I had yesterday with a customer. So building tests or working with those services or communicating changes can be a challenge as well. And obviously this character yesterday wasn't communicated that the service wasn't available when he required access to it to run his tests. So planning and collaboration and organization can become a bottleneck, right? When testing, and that can become frustrating in the workplace, and that can also have an effect on sprints, or it can have an effect on features that are being released and things like that. So like something as straightforward as a UI test can fail because of issues or instability at lower levels, and this can affect anything from data to APIs as well. And it also, with a multi-layer system like this means that, an issue at an obscured layer, and we can have a really tough time trying to figure out and pin down where this issue is. And why might the service fail? It could be due to unstable test environments, teams updating and changing services at will, bad data misaligned, and maybe your API changes from a design perspective and that hasn't updated, and then your tests are running against an out-of-date API specification, for example.
And that's going to be one of the big key scenarios, is that an API is changing, especially when you're doing a design first approach and then coding then afterwards, because the design may change while you're actually physically coding it.
Exactly. So how can we start to apply virtualization to eliminate some of these pain points? Okay, so just going into this a little bit more, let's go back again. So, as we mentioned in the last screen, an application can look like it calls single high-level service. But on the screen here, you can see that there's a dependency on a larger network at varying depths, right? Depths and varying layers. So virtualizing a single high-level service, that's very easy and common to do. It looks like in a traditional mock. And typical traffic flows can be recorded based on actions performed in the UI.
I like that one. Yeah. That one, especially, as someone that is new to virtualization, some of the people have said that they haven't come across virtualization before or mocking before. And that one for me is key. You said, Ron, a few times that ease of use of being able to kind of virtualize APIs, because APIs can get quite complex, but kind of just being able to click on a button and record the traffic and record the API requests and responses, and then generate a virtual API from that, again, is important. Yeah,
definitely with, probably more so with third-party APIs, but very often with, if you have siloed teams, the ability to remove that dependency from another team, maybe in another location. And, even when it comes down to isolated system testing, and you want to remove the dependency from third-party APIs. And there's various different uses for how we can build API virtualization into the software development lifecycle.
Sorry, just a quick question.
Yeah,
I keep asking questions, and
that's good.
that's just me. For the audience, how many people are actually? I don't know if we've got it in a poll on, do we? How many people have actually got third-party APIs, or are dealing a lot more with third-party APIs than internal APIs? Just curious. It's interesting there on, like, there's a big percentage of one particular point.
Yeah.
Which I don't know. In your experience, is that something that's quite common?
Everything is used locally. Like I would say that would be mainly reflect kind of a development. Where I'm running lots of tests in my own local environment, and I need to virtualize a service and run it locally for those tests. Or maybe I just want to spin up a virtual service and run my own UI tests about it. And it kind of takes us to a couple of different scenarios. So for example, a single high-level virtual service. So when we don't really care about the validity of the data underneath it, and we may be building tests at the UI layer that will run in a CI process. And we just want to make sure that we get a mock response from that API as part of so it doesn't break our UI tests. Secondly, then you have low-level virtualization. So it's going to end that poll now, but it's very interesting. Thank you. Secondly, like low-level virtualization. So if you have a problematic or unstable service, and if that's shared by multiple higher-level services, we can isolate and virtualize, to try and harden it, I suppose. And this lets it still fit into the work process, but we can work on the actual service without bringing down the entire stack above it. And then if we look at, okay, so this is kind of what we're talking about here from our layers. And if we look at, virtualizing a full layer virtualization. So we know at a certain point, things take over from the services we're actually trying to test to the back-end services that support them. So it could be messaging layers or DB layers are a good example of that. And in some cases, we want to allow certain requests to be made back into the lower level services, like for things like authorization flows and things like that. So a couple of different scenarios of how we would do it. So virtualizing a full layer, we can capture that traffic across it. And we can provide a large scale virtual environment across teams. And we'll look at this, how we can create our local services, and then we can deploy them into a central location so that all the systems and users who need to access that service can, and it's a centrally managed location.
Yeah, I think it's become more common in the API economy is, as you said, Ron, there the gateway services that handles the routing of that. And I know some of the people have mentioned AWS API, which is a common API gateway, something that we certainly support there as well.
Yep. Okay, I'm just going to pop open one more poll question. Just again, as Damien mentioned, this is great information for us, because we can feed this information back to our product teams, and it definitely influences and affects how we add new features and functionality into our tools.
You're keeping them busy today.
Yeah, I know we do have two more polls there, but we'll wait a few minutes and let's build something, and then
let's give the audience a rest.
Give the audience something before we ask for something back.
Yeah. Let's sip of their coffee. They can relax for a few minutes.
Okay, so from a demo perspective, what are we going to look at today? I'm going to just build some kind of quick examples just to kind of highlight maybe what we've talked about briefly today. So, for example, creating virtual services from existing sources. So recording traffic from tests or an application. Building intelligent services, so building something from maybe an API definition, designing the logic around it, creating dynamic data, mimicking service behavior as well. Excuse me. So when you talk about mimicking service behavior, we could simulate things like latency or congestion, And maybe if we're integrating with third-party services, we don't have a sandbox environment where we can simulate that third-party service failing. And it's something that we really need to know, what happens when these third-party services fail, what effect does that have on my applications and systems? I would like to know that anyway before I'm in a production environment and have some sort of contingency built around it should those third-party services fail. And then we're going to look at sharing virtual services. So how do we do this in a structured manner? How do we, keep everything in source control and, version those virtual services we have everything up to date in the central location. So we'll certainly take a look at that in a second.
If your tests are built in a specific environment, okay. So we've got test, UAT, dev. So what kind of issues might you have? And again, I think multiple choice as well. So while Ronan is setting up there, I'm not going to sing. No, I'm not. No, it is. It's one of those things that, as you can see, Ronan looking through, kind of setting up the environment. It's the ease of use of the tool, and I think looking at some of the polls here, again, moving from different environments because your test environment might not be up to date compared to your UAT or your dev or your SIT, and certainly your production. Like usually your SIT and your UAT and your production are kind of similar in kind of versions. So kind of having those together, but yeah, it is one of those things where you're kind of moving from different environments. Normally with APIs, they might become a bit unstable, and being able to kind of work through that as well. I think what you can see here, we're seeing a 50-50 split between drifting from other environments, but also bad or unusable test data. And again, it's always been, regardless of whether you're working on APIs or whatever, the test data, if it's not cleansed properly, certainly causes issues, whether you're in a different environment or whether you're in a different API. So again, good to see that kind of split across that board.
Okay, perfect. So you should be able to see my screen. We're in Ready API 2.6. So if you haven't seen Ready API before, my Zoom button is not working. So it contains the tool SoapUI Pro. So create your end-to-end API automated tests. And use that setup then for regression testing or pull those into a pipeline to run your API tests against. Load UI Pro, then you have the ability to reuse the test that your QA team have already built. So take a functional test that ensures or checks that an API is functioning, and then try and run it with 100 or hundreds of thousands of simultaneous users to see how your API performs under load. And then virtualization. So a couple of things we can do here. We can create a virtual service from an API definition, from live traffic, which we're going to do first, or we could maybe mock something or prototype something quickly, okay, and build it manually. And when we talk about a virtual service from an API definition, we're talking about a open API specification, so a Swagger file.
Which SmartBear own, by the way?
Which, yes, indeed. Well, yeah, Swagger, of course, is open source.
Open source, yeah.
We have Swagger Hub, which is a collaboration tool for working together on API design and development. And of course, Swagger Hub will auto-generate our API docs for us as well. So we'll have a look at a couple of examples first. But create a virtual service from live traffic. So let's try this first. Okay, so essentially here, what I'm going to do is I'm going to try and record some traffic from Google Maps, because for the sake of this, I run some sort of a business or service that consumes Google Maps, which may show my location of, our office, for example, or other geo-based information. Am I going to build something like that? No, Google has it already, so I'm going to consume that into my own application. But what happens when, I need to run isolated system testing or isolated load testing on my systems, and I don't want to be calling out to these third-party services? If I'm running, for example, load tests with 100,000 virtual users, and I'm running that over an extended period of time, we're going to rack up some charges against these third-party services, and we might even have thresholds or limits with how many requests we can send. So this is the URL of a real API. Okay, in this case, Google Maps. And what we're going to do is we're actually going to send requests to a virtual service that we have just created here now. And we're going to route it to Google Maps, and we're going to record all the responses. And then essentially I have a limited edition or a virtualized version of Google Maps that I can run in my local environment, and I've removed that dependency. And this goes for any third-party service, maybe payment providers or APIs that are controlled at other teams within your organization. You can do this as well. So in this case, what I could do is I could use a client like SoapUI or any other API client like that to send requests to the mock service. And in this case, I'm just going to pop open a web browser. Can you see that browser on the screen, David?
Yep.
Yeah, perfect. So what you can see here is I'm just hitting localhost, right? We're passing an address parameter of Galway. And when we hit the mock, or the virtual service in this case, we are routing to the live API, and then we're going to record the responses here. Okay, so let me just record one or two more responses. So here is Galway and Dublin. Okay, and
Mail. Have to.
We'll put in Westport.
Oh, geez. Oh, that's not too bad. I'll give you that one.
Yeah, is that okay?
That's okay.
Right, and I'm going to try and get something back from the API that gives me 0 results as well, right? So instead of Westport, we can put in, hopefully there's no address like that in Google Maps. Okay, so we get 0 results, right? So let's stop our service from running here, right? Let's maybe just rename it to something that makes it a little bit more sense. So we'll call this Google Let's call it Google Maps. Virtual API. Makes sense, doesn't it? Okay, so I'm going to stop and turn off routing. Okay, and you can see with routing as well, there's many uses for this. Sometimes we might want to send a request and get the response from the live API, especially during maybe something like iterative development, where we're developing that API and releasing functionality, every couple of weeks, maybe after a sprint. We may want responses coming from the live API, and we might want to virtualize some of the methods maybe that haven't been coded out yet. So we could certainly use routing to, depending on a request, return a response from the production API or from the virtual version of it. So we're going to turn off routing, and you can see that I have recorded these responses here. If I go into my editor, you can see we have that full JSON response from Google Maps. Now you can also see that there's a dispatch style, and we can configure this at each method level, right? So what ServiceV has done in this case is it's built or configured this dispatch strategy for me already. And if you look at the configuration of this, you can see that I'm going to just change my default response here. Actually, let's rename this to results. Okay, so if you see the rules, right, I'm just going to open up one of the rules here that's been pre-configured for us. Basically, if the query parameter address is equal to Galway, then return that response that we just recorded from Google Maps. So it's already configured for us, and we're pretty much ready to go. So now that routing is turned off, I can run the service locally here and put 8088. And if we go in here and pop in maybe address value of Galway, we should get a Galway response. Okay, and now we're getting a response. It looks like it's coming from Google Maps, but it's coming from our virtual service here. So just to prove that I am getting a response here, I'm going to go in and actually edit the response, right? Which is another pretty cool thing that we can do on the fly. I can say Galway is in the west of Ireland. Okay, I didn't need to stop or start or anything here again. I go back in here and we'll hit F5. And we get our updated response here. Okay. So now we have essentially a limited version of Google Maps running locally. So for example, if I wanted to send a request to Google Maps to get some value and use that in a request to another API, I can string test steps together in SoapUI very easily now, as I would working with real services. So actually, you know what I'm going to do? I'm going to show another example before we show how we can share and deploy these services. Right?
Okay. Is what Ron has shown people, does that make sense based on what we introduced at the beginning and also in real life now, what we're showing from an example point of view where you want to virtualize that? Like, no, we talked about the very simple way of recording, an API, virtualizing API using just recording traffic. So again, if there's something you don't understand or it doesn't make sense, let us know. We're here to answer those questions. Because we're only going to just touch on this virtualization. Virtualization is a massive, massive part of API, not just testing, but also design and creation as well.
Okay, let's have another look at an example before we kind of talk about how we're going to deploy and share these services into a central location, right? So in ServiceV again, we've just created a virtual service from live traffic. Okay, and as I mentioned, this can be third-party service, this could be a virtual, or this could be an API that's out of your control, right? And you've now kind of taken it locally, and you have it available to use on an individual basis. But what about a virtual service from an API definition? Okay, so I'm going to take a Swagger definition here, right? So in Swagger, my team may be designing this pet store, virtual pet store API, right? That if you've used Swagger before, you'll have come across it. It's one of the APIs that they use quite a lot for playing around with and understanding how to use Swagger. But very often we're going to be we design our API, so from a design first perspective, then we generate our code or client SDK, push that to source control, and our developers start building the business logic behind that service. But in the fast-paced world that we live in nowadays, I can't really afford for my testing team to sit around waiting for weeks to have access to this API to start building their tests. Secondly, I probably need this service pretty quickly if I'm running, CI pipelines, or if other services or other companies are reliant on this API. So I can essentially virtualize it from an API definition and have it available now and have it working in a similar way to the actual API will be working once it's developed. Okay, so this is my API definition. It's a JSON file that I pulled in from Swagger Hub. Okay, and we're going to go in and modify this service. So from our API definition, we have all our methods here and our resource paths, right? So for example, if I scroll down a little bit, and maybe just to put a bit of context on this, why don't we have a look at what it looks like, what our documentation looks like in Swagger. So at the moment, this is our Swagger pet store, right? And Swagger is going to auto-generate that documentation for us. So for example, I can see here that, okay, I can submit a pet ID here to get information about a pet in this pet store. And Swagger has mocking built into it, right? So you can use an integration called auto mocking. And what that does is it allows you to send a value, run a request, and get back some sample responses. Okay, and these have been defined when you're actually building out your API. But this is a static mock, right? So there's no logic there. It doesn't matter what I send, what value I submit up here. I'm going to get back a static response, right? But what we've done now is we're going to take it to the next level. And I want to build a virtual API that, depending on the information that I send in my request, I want to get relevant information back in my responses. So now, if we scroll down here, you can see the way ServiceV has taken in that API definition. We have our get pet by ID request, and we have some sample responses here. Okay, so like a 200 OK XML, a 200 OK JSON response, and response 6 is a 404 not found. These have been defined in my API definition. So what I'm going to do is I'm going to build a little bit of logic around this, right? So let's run and see how it works at the moment. So here's my service running. I'm going to go back to my project, minimize all those projects that I should have probably tidied up, but it's busy. I'm tidying up all the time here.
Housework.
Yeah. So now we have our get pet by ID sample request. Okay. So let's run it against our local mock that we just created on localhost and port 8088, because that petstore.swagger.io endpoint is not available because we haven't developed it yet. Okay, so we're going to point to our mock in this case. It doesn't really have any logic around it. I'm going to send a request and I'm going to get a response back. Now, I'm going to pop into the raw tab here so we can see everything that comes back, right? So as I send requests, we're just sequencing through those responses. So this is kind of like a mock scenario, right? Where, you know, I might be able to randomize the responses or get the responses back in sequence. If I want to do something a little bit more, then I'm going to start writing GroovyScript or some other language to control that.
So it's all predefined. It's all out of the box, really.
Exactly. Right. So there's my 6 responses. So now I'm going to actually put a little bit of logic around this, right? So in ServiceV Pro, we have our get pet by ID, and I have a number of responses. So with response 6, I'm going to just put in some JSON code which says results not a valid ID. Okay. And in response 2, let's go in and edit the value here, and we'll put in let's put in hello from sunny Galway. Okay. Now at each method and resource path level, we can set a dispatch style. And as you can see, by default, it was set to sequence. But now we can control how those responses are dispatched based on, you know, if it's XML, we could use a query match or an XPath match to match some request information and return a response based on that. In this case, I'm going to use a parameter dispatch style based on that pet ID path parameter. So in my parameter here, in my dispatch style, we can return response 6 as our default response. Okay, so that's not a valid ID, for example. And I'm just going to create one rule here, okay, just to show you how it works. So in this case, we have a path parameter called pet ID. And if that's equal to a value of 2, then I want ServiceV to respond response 2 for me. Right? So now let's go back to our projects and fire in the same value response 2, send a request, and we now get back hello from sunny Galway. All right, so here's my JSON response. We can look at this outline view. If I'm building tests against this service in SoapUI, I can now start adding assertions and checkpoints and validate that the response I get back is what I expect. If I put in a value of 4 and send a request for that pet ID path parameter, we get not a valid ID, right? Because we've only one rule, and that rule at the moment is only for a value of 2. Okay, so let's go back and fire a value of 2 again, and we get that response back. So hopefully this is enough to kind of, demonstrate how quickly we can control how these responses are dispatched depending on this method here as well, right? And we can quickly control that through built-in dispatch styles of the service V. We can, of course, and will need to in some cases use a script dispatch method, because maybe we want to manipulate the request parameters. Maybe we want to take a response and do some manipulation on that before we return a response. And we can certainly do that as well. But essentially, most of the dispatch styles that are included in the tool is going to significantly reduce the amount of scripting that we need to do. I'm going to just show you something else as well here. So say, for example, we want to actually connect to our test data and return that test data in our responses. Maybe this is the data we're going to use in our actual API. So we can connect it to our data sources. So via JDBC, pull information from the database. And this kind of makes our virtual API even more realistic, right? Now, for this example, because we're a little bit short for time, I'm going to set up a quick data source and a property. And instead of data driving my responses from a file or from a database, I'm actually just going to use a tool, this data generator, to just generate some random data. So for example, say we wanted to generate some unique IDs or something like that and have them come back in our response, we can do that. An example of why we would want to do that is maybe I want to generate a session ID and pass that value into another call to a service, right, to simulate something like a session. So what I'm going to do now is we've generated some random data. I'm going to point to that data source. Then in my response, instead of saying hello from sunny Galway, I'm going to just return this unique ID, right? So within my JSON here, I can simply right click and I can use this get data function to pull data into my tests, right? And this is the property that we just set up, right? So now we should return random unique IDs when we send requests. So if we go back with this value of 2 in our request and start sending responses, you can see that this value is now being generated from that test data. Now it's random at this point, okay?
But again, you can put some logic around that.
You can put some logic around it, and even in ServiceV, if we're connecting to a data source, for example, something like a JDBC connection, we can use prepared properties. So when I talked about that example earlier on where I send the username and a password, I could use them as prepared properties to create dynamic queries. So if, username Walsh, password I love mayo, we could use them as prepared properties to pull that information from our test data and return a record based on that information. Make sense?
It does. Does it make sense to everybody else? Hopefully everybody else is still there. Again, is this making sense to people? Any questions? Don't be shy.
Okay, now it's about 10 minutes before we finish up, right? So just let's see if there's any questions coming through. But very quickly on the ServiceV side of things, I can simulate behavior as I talked about earlier on. What about if we want to get our service to start returning errors? Can we do that? We certainly can. And actually, why don't we do that, right? So let's say, actually, it might just make a little bit more sense to do it on Google Maps. So let's go back to Google Maps.
But the other thing you can see here, what Ronan's doing is it's easy to use. As Ronan said, some of the stuff you can do with scripting, but a lot of this can be done by just adding parameters, adding queries, all that kind of stuff, adding paths. Yeah. So it's important to kind of see that if people are new to kind of virtualizing and APIs, it's not necessarily a bad thing. With kind of what Ronan's showing you here. It's the ease of use of the tool and virtualizing those APIs and working with, conditional response and requests that are coming in from that, and how you can actually manipulate a third-party API, which, again, is something that's used as you continue to evolve your APIs as well.
Okay, so I'm going to, as Damien mentioned, we're going to simulate an error, a service unavailable. So we're going to basically simulate an outage, right? We're just going to do it for 5 seconds. And let's put in, just put in an error message, we can see it here, right? Okay, so let's run our service, and we should start getting an outage after 8 seconds. That outage should last for 5 seconds, right? So let's run this, go back into our browser, get a response back. All right, get another response back, get another response back. Oh, Google Maps unavailable, right? So our outage is going to last for 5 seconds, and we're back in line. But you know, we can very quickly simulate those errors from APIs that we're dependent upon.
Exactly. So negative testing as well is important. Like, you know, you like to have the positive testing, yes, all the green check boxes and all the green signs, but ultimately as well, you need to do some negative testing. What happens when the service is unavailable? What happens when the API is unavailable? How long does that last for, and so on and so forth. So again, that's another scenario you can work with.
Yeah, exactly. Okay, so this service is useful to a point, right, when I run it locally. If I want to run, you know, if I'm a tester and I want to, you know, run my tests against a virtual service, build up my test cases, have them built in anticipation of getting access to the real API. Maybe my tests are dependent on a third-party service like Google Maps, but I don't want to use it, so I virtualize it and have it stand in. But you know, generally we want to have our virtual services in a centralized location so that all the users and systems who need to use it can. So what I'm going to do is take this local service here, and I'm going to deploy it onto VertServer. VertServer is a lightweight tool that basically can sit in a VM or on your network 24/7, or maybe you want to spin it up in a container as part of a CI pipeline and automate it. We can certainly do all of that, right? But I can take here this local service, drag and drop it onto VertServer, and now it has its own IP address, right? It has its own endpoint here. And any user or system that has access to it can now run their tests against it, right? So it's deployed onto it.
So it's basically a shopping cart for VertServer.
It's like a sandbox for your virtual services, yeah. That can be run in various different ways. And if you think about our pet store here as well, so let's just rename this pet store version 1 mock. We won't call it a mock because it's not. It's a virtual API.
So yeah, so this would be good for teams that are dispersed, different projects.
Absolutely.
Yeah.
If you're building services that are being consumed by, you know, other companies and they want early access, you virtualize it, deploy it onto a sandbox, give access to it straight away. And then they're not hitting your environments either.
Mm-hmm. So again, that's something that come up in the chat is some people are looking to develop their own APIs and allow it to be accessed by third-party people or systems. So again, that kind of thing would help in terms of accessibility as well.
Sure, I'm connecting to the right VertServer here. While that's loading, let's go to, there's VertServer UI as well, right? Which we'll just have a little look at. I don't have any. Okay, so this is VertServer UI. Let's get back to where our pet store is.
So guys, keep the questions coming in. I'll answer them as they come in as well.
Okay, so just to give you a quick look, this is VertServer UI, right? So I have VertServer running. Do I have it running, or is that the issue? Yeah, I have it running here, right? So you can see this little console box, VertServer is running, Java application. Here's my virtual services. Here's my pet store. Let's deploy that onto it. Pet store now has its own endpoint. So I could go to my QA team and say, oh yeah, we built the pet store app, start building your test or scoping them against it. Okay, and have access to it pretty much straight away. And VertServer UI, this is just like a high level dashboard that I can see all the virtual services within my organization that are running on VertServer. And we may have multiple VertServers running in different environments within our organization as well. But you can see here, I can run these services, and everything I'm doing here is manual, but we can automate this entire process as well. But now, like, I have, this could be open banking APIs that are virtualized. This could be our pet store. It could be Google Maps or various different internal services that we're working with. So I would think as well, legacy SOAP services that haven't changed in years. Maybe we're moving to design first, more REST APIs. I could take those SOAP services, virtualize them, deploy them on a sandbox like VertServer, right? So they're still running on that. But essentially here you can see that we've now deployed onto VertServer. I've actually 76 different services deployed here. I only have 2 running at the moment, right? So once, I would always say about ServiceV is, this is where I go in and design my virtual services. I build them, I build a logic behind them, I data drive them. And then we can deploy them once they're ready into VertServer, into that central location. Now, there's many different ways to run VertServer, right? We could run it as a service in a Linux and Windows environment. We could have it running in a VM. And as I mentioned, we have integrations with containers like Docker. Maybe I want to run a pipeline, spin up a Docker container with VertServer on it, deploy some virtual APIs as part of that CI pipeline, and tear the environment down afterwards. Certainly have a look at the documentation about readyapi.smartbear.com, and there's lots of information about different ways to run those services as well. Okay, so let's just see, we have one more poll question I'm just going to throw up and see if there's any questions coming through and kind of what you've seen so far. Has this been useful? On first glance, if you're just looking at it, does it seem something that's very easy to use, or any feedback would be excellent. And I will launch that final poll, Damien. Just while that poll is running there, a couple of things to mention as well. Like when I set up a project in Ready API, I could import an API definition, start building my functional tests, build virtual services, maybe have another team who are running the load and performance tests. When I set up that project, we have a native integration with Git, right? So I can manage the versioning and control all my tests by syncing with a repository or a specific branch, right? That allows multiple team members to work on the same project together. So you could have your performance engineers, QA testers, maybe the developers or more technical people who are designing the actual virtual services as well. And we can ensure then that everything is controlled from a versioning perspective. And so, for example, if I am a load and performance tester and I want to come in and pull down some functional tests into my client, start spinning up load and performance tests, I can do that, reuse that work. If I want to know what virtual services I should be working with, well, they're going to be contained in source control and then managed and controlled and deployed onto VertServer.
So one question there on that just came in was around once the service is deployed on VertServer, can it be accessed at the same time by multiple teams?
Absolutely. Yeah. It's just like an API, except it's sitting in Sandbox. Like what we've done is we've deployed virtual services onto VertServer, and we've actually run load tests, where we've had thousands of simultaneous users sending requests to them. So you can absolutely do that. And one of the new features that was brought out as well, which is kind of handy for ServiceV or for VertServer, is the ability to run virtual services on the same port. So up to maybe the last release, each virtual service had to have a different port number when it's running on VertServer. And this, caused, some problems for some teams because, with restrictions, it wasn't that easy to get, various different ports open on a regular basis. So now we've added the functionality to allow you to run virtual services on the same port. And I think this is a big thing as well, and kind of removes a bit of hassle as well for people.
So again, guys, thanks very much for all that. Hopefully it was of use at some stage. So again, all the information we've shown here is on the latest version, so 2.6. Obviously we have new releases every quarter. I think 2.7 is out soon as well. So any information we've shown you here is available on the latest releases. If you do have any other questions after this call, please do reach out to the team here at SmartBear. And again, keep a lookout for any other kind of webinars that are happening. We try and make it as informative as possible and what's happening around trends and all that kind of stuff. So again, hopefully you guys got some good information from this. And again, thanks for your questions, your feedback, your interaction today. And as I said, hopefully we shall see you back again soon.
Perfect. Thank you very much.
Thanks very much, everyone.
Nice weekend, everyone.
Have a good one. Bye-bye now.